All right, I think we're live. Hello, Holmes.
Hi.
Thank you for joining me for this. And as I said, I'll just ask you to introduce yourself and tell me about what you're building.
Sure, yeah. So my name is Holmes Wilson. I'm an activist and a software maker. The thing I'm building is called Quiet, and it is an attempt at building a totally peer-to-peer and private and very secure alternative to team chat apps like Slack and Discord, um, without relying on servers at all, and in this sort of totally decentralized mode. um, and yet still with like all the features someone would expect from something like Slack or Discord, including support on desktop and mobile and things like that.
Cool. And why are you doing this?
Yeah, so I think the project stemmed from just a general frustration I had that I worked at the Free Software Foundation, actually, the kind of spiritual home of the free software movement, or the sort of custodian of the free software movement in 2010. And I really believe in free software and in the structural guarantees, sometimes called open source software, right? They use those terms interchangeably, or those terms are used interchangeably. And I really believe in the structural guarantees that free or open source software give to users in like a political or power sense, where if the software maker starts going rogue and adding features that you don't want, you or someone else in the affected community can make a fork, change it, and release that new version to the community to kind of repair the damage done by the rogue software creator. And I think this kind of power is something that's really missing a lot of the time in tech, because a lot of the stuff we use isn't free software, and so we end up in this situation where people just like are using tools they don't really trust, and using tools that feel bad, using tools that are kind of always trying to get them to like pay more attention or watch more ads or spend more time, or just like that are kind of standing in the way in different ways, or that don't make them feel safe, right? Or that are compromising their privacy or their security in some basic ways. Or I think the other problem is like, even if the app doesn't feel bad, you don't really have a basis on which to trust it. It says the messages are private, but you know, are they? And like, how are they dealing with data on their end? And I think uh, over the last few years with the tech lash, there's just been this like huge lack of trust in the tools everyone uses, and it kind of is turning people's experience of a medium that could be of the internet, like a medium that could be so democratizing and beautiful and like expressive and connecting, and could be so utopian in a lot of ways, into kind of something more like a dystopia. And anyway, to make like a long story short, like I, I saw like the rise of Bitcoin and then Ethereum as like a potential way to address that by building a stack that would let us make that would let us make apps that were based in free software and shared, not like the free software apps of the early 2000s, like VLC or Firefox, that would just run on our computer, or Open Office, right? That would just run on our computer, but rather shared free software apps that would run on many people's computers, but connect us together. Um, Bitcoin and Ethereum showed the promise of perhaps like a path to doing that, but the blockchain space and Web3 space generally have been very slow to make tools that actually change like the power and privacy that I could enjoy in my day-to-day life by using an app on my computer or my phone,
Right.
especially outside the financial realm. Like, great, like those tools gave us a way that I could send you money and receive money and, maybe speculate or trade, certain things. But like in terms of the apps I really use day to day to do work, like Google Docs and Slack, and the apps I would use with my activism team at my former organization, Fight for the Future, which I co-founded, where we were doing like really high stakes activism on policy questions in the US. Like we needed tools that let us communicate fluidly and securely every day. They were extremely reliable and resilient, and like we were just so dependent on centralized stuff for that.
Yeah.
And so anyway, the reason for the project is a frustration that with that, and an attempt to build something that was really usable, that would impact my day to day and the day to day of other working teams in a positive way, that like didn't that was totally untethered from this dependence that everything has on central servers and big companies, and would work like the peer-to-peer file sharing apps that I grew up with in the early 2000s. They would just kind of
Right.
it would just work.
Yeah, it's funny. Like I came through the whole open source and FSF world myself, and have for decades been a proponent of open source software for the reasons that you mentioned. But there is this like loophole that happened when everything started being hosted by others, because I definitely remember a point where I didn't trust the app server I was running. Now, I didn't think they were doing something nefarious, but I was running a commercial app server. This is the late 90s at a big enterprise, and it just didn't work. And I knew, like, there was one time that I literally found a Y2K bug in maybe 2002 or so in an app server that was commercial, because I broke the rules and decompiled the Java classes and like had to prove it to them. But my $100,000 a year support contract did not result in them finding it. I was like, I know it's a Y2K bug, So like that sort of trust, when you're running desktop software, it does apply to users in a sense. I mean, not every user is going to read the source code, obviously, but at least that's possible. And there's
At a community or collective, like herd immunity kind of level, it does.
Yeah, but then like I could build a business where I open source everything, but I'm running all the stuff on private servers you can't see, and you don't know that I'm even running the same version of the code. You don't know how I'm dealing with the data.
Yeah.
You're right. So,
yeah. And most people don't have servers, and until they cost $5 or $10 and are extremely reliable, most people are not going to have servers.
Right.
The closest thing to someone's server is going to be their phone or their computer. And so when you make software that depends on a server that's free software, the software freedom guarantees you're giving are to the server operators mostly, not to the people. And that's where it all broke. And it was a really serious break. And I think I don't think people fully appreciate how big a deal this was, because I don't think people appreciate generally like how much free software was responsible for making the apps that we use every day, like kind of keeping them honest. And then when we started depending on servers and those free software guarantees disappeared, I don't think people realize how much we lost. Like, free software doesn't just protect you. If it's working properly, it doesn't just protect you if you're using free software. Like, you could be using, stuff by Microsoft, but the fact that Linux exists or the fact that OpenOffice exists is exerting a type of pressure on them, a competitive pressure, giving people this power to jump ship that holds them accountable. And if the proprietary software gets too bad or too rogue or too manipulative, people have that way out, and that keeps the whole ecosystem honest in a way that's like hard to measure, but definitely present. And so when you take that away, which is what happened when everything switched to the cloud, you just get like this total power imbalance, and there's nothing really to keep these companies honest anymore.
Yeah. So maybe we should now get concrete and talk about what you're building and show it.
Sure. Yeah. So I have a demo here.
Okay.
Let's see. Cool. So here I'm just running a few instances of my chat app and just a little demo community I made. So as you can see, it's it looks a little like Slack or Discord. There's like a channel on the left with a sidebar on the left with channels. There's a chat window. I've got 3 users here who are all in a community together. One thing to note is that we are targeting the like Slack Discord style of messaging and not the Signal WhatsApp style of messaging. By that I mean, like, we're targeting the case where you're in a team or a group of people and that group is bounded and you let people in, rather than the use case where you have like your entire social graph, your whole phone number, contact list, and you can just kind of message with everybody the way you can in WhatsApp or Signal. That former use case is much easier given the current state of peer-to-peer tech to build a satisfying product around, for a bunch of reasons, which maybe we'll have time to get into. But anyway, this is like something like Slack or Signal. Slack or Discord. Oh, hey, I can send a message. Here it is. It appears on my other devices. And I can reply, and I can reply with a nice emoji. It's working. Cool. I can also do things like send files the way you would in a normal messaging app. So let's see, send this file. I've actually already sent this before, so I'm cheating a little bit. Hey, this is a GIF. I just tested it earlier. And file is sent. It arrives really fast because it's sort of automatically deduped. But yeah, here, so we have a GIF on all sides here. And yeah, this is pretty much it. Yeah, the mobile version, we've only released it for Android so far, but it's React Native and will work on iOS soon. Background notifications are a wrinkle on iOS, but you know, yeah.
Cool. So
See,
that's
I'm gonna
Android
switch.
on the right side of the screen, and then I assume Mac OS, two different clients.
Yeah, it's Linux app image actually. So Linux, and Android.
Cool.
Um,
I outed myself as not being quite as nerdy as I like to pretend I am, I guess.
my stack is weird. I'm actually using Linux in Chrome OS, which is I jumped ship under duress from Mac last year. I just couldn't. The CSAM, the local scanning stuff that they were planning was just like too creepy, and the fact that they didn't end up doing it, but the fact that it was even on the table internally as an option just made me be like, all right, I'm done with this company. So I'm on my escape hatch was a partially free solution. Chrome OS running Debian and a VM. That's what I use for my day-to-day now.
It's a surprisingly usable environment, Chrome OS with Debian. It's nice.
Yeah. So let's see. I could I'm going to close some of these actually because I had some other stuff that we might want to talk about or walk through. Just going to kind of let's see. So it might be helpful to look at some of some of how this works and. But yeah, did you have any questions right off the bat, just seeing the demo?
Yeah, just to reiterate, there are no servers involved in doing this. So like, if you're a user of Slack or Discord, you might look at this and go, oh, okay, what's the big deal? I've been doing this already, right? But in this case, you're not connecting to a server and you're not logging in the way that you would normally do with a Web2 application, right?
Yeah, that's correct. And that's the key thing. And it actually takes, so one really significant thing I would kind of communicate to, well, first of all, let's go back a little bit to the why of this. I sort of said what my motivation was, but I didn't say all the advantages. So the advantage of doing something like this without depending on servers at all is that you get all the benefits of running something on a server that you yourself host, running like free software on a server that you yourself host and control for your particular organization or community, except you don't have all of the hassle and cost, and in some cases, like practical impossibilities of running a server yourself. So that's I think a really significant thing. When a lot of people on this call might, or a lot of people watching this, like in our particular audience, might just like spin up an app on a server all the time for different reasons, for home media center, or a matrix for friends, or for your own team. People might be comfortable doing these things, but let's just like stop and think how much of a hassle it is and what risks are involved. So when you have something running off a central server for dozens or perhaps hundreds of people who are really depending on it to do something important together, say you're running a matrix server, you are the single point of failure as the server operator for all of those people. And if anything goes wrong, it is an emergency. You have to fix it really fast because people's time is going to be wasted. People are going to, people's work is going to be disrupted. So the burden on you is really high. If you're doing that as a volunteer, or even just as like a busy member of a team who's supposed to be doing other things, that is a real strain, right? Like when it blows up, it's a real serious issue and it's a stressor. So it's not a very sustainable thing for you to be like supplying that service for free to a lot of people. And then once you get into like sort of something like paid hosting, you're back kind of in the same problem that we started in, where now you're trusting some group of people is trusting some other entity to run the server for them. And probably if they're doing that, they should just be using Google, or they should just be using whatever the biggest and baddest like tech company is that has the biggest and most well-funded security team. Because honestly, like some friend of theirs or some small operator that's trying to be really cool and offer them this service is not going to do as good a job securing their data as Google is. So there's this kind of like thing there where the privacy benefits you get only apply if you're running your own server and doing that at an extremely high level of reliability and sophistication when it comes to securing it. And that's just not like a thing in the real world. Another thing with running your own server is that, sorry. Oh, that I was just feeding back. Another thing with running your own server is that you don't get like, you need some other server running just to check that it's running if you want to achieve any type of reasonable level of uptime, and you need some type of observability and some alerts if your server starts lagging, and that just creates another hassle, another cost, another potential point of failure, right? Like, how do you know the server that's supposed to send you a text message when your server goes down is still working? And so what we're achieving here by making a peer-to-peer app that works without relying on a server is really, really powerful and useful in practical terms to people who want that level of control over their data, but aren't like the Google security team, or aren't like someone where aren't so sufficiently well resourced that they can just effortlessly maintain and secure a server.
Right. So we have peer-to-peer. Everything is encrypted, I assume, and from what I understand, it is also anonymity preserving, if that's the right way to say that. These are the characteristics of how Quiet works, right?
Yeah, and so on top of the benefits of the privacy and security benefits of controlling your own infrastructure without the hassle of running your own server, we also end up achieving some privacy properties that are actually really hard for centralized services to provide, even encrypted ones like Signal. So first of all, we get into encryption based on the way we're using Tor. All connections are made between Tor onion addresses at like the network layer, and so you benefit from encryption in transit just right out of the box. We haven't even added our own message layer encryption yet. We will someday, but already we can rely on Tor to provide that. Then the next thing you get, so that gets you up something to the level of a Signal, maybe without some of the subtleties like forward secrecy. But what something like Signal has a hard time providing is protecting metadata. So for example, if your phone is seized, if you're doing like sensitive communication around an activist issue, for example, and your phone is seized at a protest and the police get into your phone, all of your contacts and social graph are in there. So even if you've had disappearing messages turned on and all that, even if they don't get access to your messages, they know everyone you communicate with in all your groups. And they know their phone numbers, so they can work backwards from that to find their identities. That's a pretty serious issue. Also, Signal collects that information just by virtue of running services. Whatever cloud provider they're using, I think it's AWS, has access to all that information too. So you kind of end up leaking a lot of information about yourself to the service provider and to potentially anyone who gets your device, just because of the way these centralized systems have to work. Whereas in Quiet, we're using Tor, which isn't perfect at protecting your anonymity. I mean, real like complete anonymity on the internet is just a really hard problem. But it is kind of the best in class practical thing right now. And it does protect like things like your IP address and who you're communicating with against a very, very broad range of attackers.
Yeah, and from what I understand, I've never built anything on Tor myself. Apparently, I'm having some sort of crazy meeting freak out. Apologies, but I've never built anything on Tor myself. In fact, didn't quite realize that was a thing you could do. Although now it's obvious now that I saw that you've done it. But from what I understand, basically what happens is you route all of the traffic through multiple layers, multiple probably physical machines on the internet. Each one of them adds a layer of encryption so that each additional hop in this sort of like routing system that Tor provides isn't able to reverse engineer anything other than where it came from at best, like the hop before it. So,
Yeah,
like you say, it's not perfect, but it's at least much more difficult to reverse engineer where something came from and the communication channels, right?
yeah, and in some ways, like it's one thing that's really important about that is that if you just kind of jump in and build a very kind of straightforward implementation of a peer-to-peer chat app, you're going to end up probably with something that is much less private than even Slack, because it's going to be, even if you end up getting the message layer encryption right, you're going to be leaking so much information to the peer-to-peer network about when the user's online, what kind of communities they're a part of, you know, linking between the different communities they're a part of, when they're active messaging, who they're talking to, like, and when I say who they're talking to, like individuals identified by identifiable by IP addresses, and then of course everybody's physical location as they move from their house to the coffee shop to, you know, another city. You start leaking all that just by default, even to like, not just to like the NSA or something, but just to like other people in the peer-to-peer network, or, you know, in the blockchain space, we have companies like Chainalytics, like just kind of data hoarding companies that just sort of join these big public peer-to-peer networks and slurp down as much as they can and sell it to the highest bidder, usually governments. All that kind of stuff becomes possible if you implement a peer-to-peer chat app the naive way. And all that stuff, I think, is pretty surprising to users and not that attractive if what they're used to is something like Signal that does a pretty good job of security. So we need to do better than that, and Tor lets us do that. And it also does a couple other cool things where Tor, for building peer-to-peer apps on Tor, well, Quiet's inspired by earlier work in the Tor space, like Ricochet and OnionShare, where those two apps in particular, Ricochet is for one-to-one synchronous DMs, and OnionShare is for file sharing, like one-to-one file sharing. Both of those apps use Tor Onion addresses, which is like the sort of way you host a site, say, or a service in the Tor network, without revealing the IP address that it's hosted on or the domain name it's hosted on. Tor Onion services are used as like identity in those things. So you are an Onion service. And then someone just has to send you a message or to get a file from you, just has to connect through Tor to that Onion service. It ends up being this very simple thing. And even though it's peer-to-peer, architecturally, it's almost just the same as like building a normal web service, but you do it through Tor. But it's very simple and offloads a lot of the complexity to Tor. And most of all, you get this like address. Your Onion address is just Onion addresses are a public-private key pair, so they're forever. They're not related to your IP address or anything like that. So if you and I join a community together in a naive implemented like peer-to-peer app, there's this problem of like, okay, well, how do I know what your IP address is at this given moment? And then you have to figure out solutions to that usually involve leaking a ton of data to some global network and a lot of like scalability problems. Whereas with Tor, we get an address that's just like, this is Chad's address forever. And plus, when we connect to it, we're connecting with all the transit encryption and privacy protection that Tor provides. So it's a nice pattern.
That's really cool. It makes me wonder why more people aren't building on Tor. But
I think there are actually good reasons for that. There are some reliability issues with Tor that are still getting worked out. And it comes up in funny moments. It'll be very reliable for years even, and then there's some like geopolitical event that motivates some state actor, say, to do a denial of service attack on Tor, and things get worse. They don't start failing completely, but they get worse. And so we've been like, there was an attack like that in the summer that's been ongoing, and we've been like just working on how to mitigate it and actually working to get more funding for Tor to beef some of that stuff up. So there's some quirks there, although performance overall is pretty, I mean, you saw when I was sending messages, it was pretty fast, latency was fine. Performance is pretty good. Connection reliability can be an issue between like small numbers of peers, especially, but we're working on that and we think we can mitigate it. And then another reason that people don't build on Tor is it's not really built to be built on. It's kind of like an old school daemon, like something that runs at localhost and you connect to it through a control port to tell it what to do. And then you can kind of proxy your stuff through it. It's not really, and then if you want to ship an app with Tor, you have to, ship the binaries as a kind of sidecar to your app, and then have like, this is the part in Quiet where wait, is it here? It's either here or here. There's some code we had to, some work we had to do in Quiet just to like make sure that, just make sure that we're like up and like we have a Tor client up and running and that we can connect to it and control it. And, if we aren't able to kill it, that we kill it before we start a new one. There's just kind of babysitting you have to do that's annoying. Tor is actually working on fixing this with, they're doing a rewrite in Rust that will help a lot with this. It'll be more like you'll be able to incorporate it as a first class, like, library or module or something. And
Cool.
It'll be much more, integrated.
Well, do you want to walk through some of the stuff that you had open here that you were thinking about showing about how Quiet's built? And to be clear, this is the Quiet repo, I assume, from your GitHub. That's accessible.
This is yep. Should I post? Would it be helpful for me to post the link really quick, or
Sure.
do you have that?
I can do that. I can do that.
Cool. Yeah. So this is stuff in the Quiet repo. So if we look here, so we're using, there are a few different components. We want to share them across desktop and mobile. So we're using monorepo, or at some point we transitioned to using monorepo. If you get into the packages folder in the Quiet repo, there is the four main ones are backend, desktop, state manager, and mobile. So desktop is our desktop front end, the Electron app you saw. Mobile is our mobile front end, the React Native app you saw. State manager is the common, is also front end, but it's the common piece to the desktop front end and the mobile front end. And it's like basically like a ton of Redux actions that just get imported to both front ends, but are like most of the business logic that's common to both. So we're not rewriting it for each platform. And State Manager is also nice because it lets us spin up headless. It's running State Manager with the rest of the backend, lets us spin up a headless version of Quiet that we can control and use for testing. And we've done a lot of testing where we spin up like a few of these and make sure they can communicate. That's just part of our integration test, but we've also done simulations where we spin up a few hundred of them and see how messages travel.
Could you use that to create bots, maybe?
Yeah, definitely. Or always on servers. We haven't rolled this up for people yet, but you can use it for a lot of things. Yeah.
Cool.
All of this, just to back up, is mostly in TypeScript. It's all in JavaScript, except for some native dependencies that are just, in just the dependencies of some node modules. But yeah, in the repo, GitHub thinks that all our code is in C just because we have a few big native dependencies, but it's all in JavaScript. So it'd be comfortable for anyone coming from the web development world to kind of dig into and get involved.
I saw like npm install and the whole sort of typical deployment or development deployment flow, right?
Yeah. A little bit, you have to do like learn a bootstrap, like for the monorepo stuff, but yeah, pretty much npm install, learn a bootstrap, npm run start gets you a locally running desktop version. And then mobile is a little harder. Probably if anyone wants to jump in, unless you have Android dev experience, it's probably better to jump in on desktop first because it'll be much easier to get started. Which
is probably true across any open source project, right?
Yeah. We'll hopefully we'll have yeah.
What's the license for this?
Oh, GPL and I believe v3. Yeah.
Cool. So totally free and open.
Yeah. And so let's see. So where to start? I guess one thing would be to follow the path of a message. So that's kind of how I was thinking about talking through this. So like here we have, I'm going to actually show the mobile version. But here we have my computer's getting laggy because of the screen share stuff. Okay. Anyway, here we have just a basic React Native chat component. So this is like the chat screen, and meaning like the list of messages and the sending of messages. So let's see. Most of this is just what you'd expect. It's not like anything. There's a decent amount going on here, but it's basically just like rendering messages and providing running a list of messages and giving us like a text input field and letting us send a message.
Like just vanilla React stuff.
Yeah, so it's what happened. The structure of the app is vanilla React and React Native stuff, all the way down to a Socket.io connection between the between State Manager and the backend. And then in the backend we start getting into some of the peer-to-peer stuff. But from the sort of basically like here, this is just a pretty much like a container that has the business logic around the chat component, I think. And then we get into a bunch of Redux actions that are called that then get passed to the Socket.io connection. And these are like the types of things that we end up doing in the app, like asking for messages, canceling a download, getting an event, the channel's sort of been replicated, getting an event that we've successfully subscribed to a channel, creating a community. These are just the basic like events that would happen. And then storage, a lot of the action then starts to happen in and in the backend, a lot of the action happens in storage, in this storage TS, where we end up kind of bringing together the IPFS stuff, like just IPFS, the P2P, OrbitDB, some pieces of OrbitDB, and I'll explain that in a second, and then getting events from the Socket.io connection, and that triggers different things at the peer-to-peer layer. So
is Socket.io doing like a WebSocket connection or a HTTP 2.0?
Yeah, a WebSocket connection.
So it's a long-lived connection that can receive events, basically.
Yeah, and that's between the front and the back end layers. And the reason why we do that instead of having everything in we could run a lot of this stuff in the browser state or in the like React Native state, but the reason we separate it out is that on mobile, you end up we want to be able to run permanently or as much as possible in the background on mobile. And to do that, you kind of have to you have to cleave the app in two, where some part of it you attempt to run in the background to the extent that the OS lets you, and some part of it is only going to be alive when the user is looking at the actual app. And so we need some type of inter-process communication that's not, for that, so that we can have like a persistent backend, and the front end just kind of gets what it needs when it is alive. And then there's like there'd be different ways to do it, but the webby way of having just like a WebSocket seemed like the most straightforward. And so let's see. So in the backend layer, the main thing that's happening when a message gets sent is that OrbitDB is we're using whenever possible off the shelf stuff for our peer-to-peer stack. In an ideal world, there would be a peer-to-peer stack that gave us all of this for free, so that we would not even have to worry about any of this. But such a thing does not exist now. There are different attempts to build like general purpose peer-to-peer stacks, but they all, when you go kind of shopping for a solution, they all have, pluses and minuses. There are some things they cover, some things they don't. And none of them, I think it's difficult for the people working on these stacks, because the number of things they'd have to do to make like a Slack or a Discord or Google Docs possible is actually quite a lot of things. And but there aren't any existing apps that sort of do these things in the peer-to-peer mode that are popular with users that have found product market fit yet. And so the stacks don't quite know what to build for. And there's a high volume of things that they would have to build to kind of be a robust solution. So we're still in a stage, I think, where where you can make a real contribution to the space just by kind of plowing forward and finding some set of solutions that works and figuring out like, what basically just making it work to the point where you have something that users can really interact with, and then you can start iterating towards product market fit. And then that, to the extent it's successful, will inform what things you need from your stack.
Right. So
There's a bit of a
Quiet might end
chicken
up
and
being the
egg.
proving ground for a new stack that could then be integrated in a more productized, hardened way, so others could come along and not have to do what you're doing. Right.
Yes, yeah. My biggest aspiration for this space is that like that will that will sort of plow through these engineering issues using available stuff, and in some cases rolling our own solutions, and build something that is able to get enough traction with users that will start growing and be able to invest more in it. But that in 5 years or 10 years, building something like Quiet, which will take us years, will be something that someone could do in a weekend hackathon with like the same performance and security properties. Because in this peer-to-peer mode, if the stack is sufficient, people don't need to run infrastructure. They don't need to think about servers. They just need to think about state and how it's mirrored across instances. Like the way Quiet works right now is basically like BitTorrent for your Redux state. Like whenever something changes in the front end state, use a peer-to-peer network to sync that front end state to all of the different nodes in that network. And then you have multiple different networks for different communities. That could be made to be very, very, very simple, especially with like, and I think there's also probably a parallel track here where like, making developer tools for dealing with front end state and the syncing of front end state between backends or multiple instances could just be easier in itself, even in the like Web2 world. And there's cool projects like working on that. But anyway, it could be way, way simpler than it is if the stack was sufficient, but you need some example products to inform what the stack should be. It's like you couldn't make Heroku before there were like a few dozen successful like Rails apps in the wild, right? You can make Heroku before somebody made Basecamp. And I think a lot of the peer-to-peer general purpose stack stuff is kind of in that position of trying to make Heroku before somebody's made Basecamp. If that makes sense. I don't know if that analogy works. But.
Oh yeah, it works very well. Yeah. So here you're using libp2p, IPFS, OrbitDB, and Tor as sort of like Tor for transport, I guess might sort of be the right way to say it. Then how do the other pieces fit together? How do they fit in?
So once the network is up and running, like once I have in the demo I just gave, those three people connected to each other and talking, it's a bit easier to describe. So I'll start there. When that network is up and running, people are connected to each other over Tor to each other's onion addresses. And if there's more of them than the max number of connections, which I believe is like 8 or 10, they'll be connected in a gossip network using libp2p's. So libp2p, OrbitDB is based on libp2p pubsub. And since 2019, libp2p pubsub has been using the gossip sub algorithm. Let's see, I can switch here. This is some OrbitDB tabs. This is gossip sub. libp2p gossip sub is the network like broadcast layer used in Ethereum 2 and Filecoin to broadcast transactions to all the nodes in the network. So it's like it's received a lot of attention in terms of like security analysis and testing. And its job is to, I just got a funny notification. Its job is to blast some small piece of information from one node to many nodes in the network. And they might not all be connected to each other if the network is big enough. So there's like some kind of epidemic broadcast thing happening where, one person gets a message, passes it on to the next, passes it on to the next, and you try to avoid all the messages going around in circles. That's what gossip sub is. And so when a message is, so people at the network layer are connected to each other's onion addresses in some type of graph determined by libp2p and its gossiping algorithm, where it's trying to connect to a diverse number of peers or diverse set of peers that are, and to the extent that in like open connections and closed connections, and maintain a certain number of connections to peers. When a new message is added, it works its way down through the normal kind of React stuff and through that WebSocket connection to the backend. And then it is added as an entry to, well, first it's validated, like does this message work? And then it's added to OrbitDB, which is a CRDT, a Merkle CRDT based on IPFS. So this is OrbitDB. Let's see.
Can you unpack those words? Merkle CRDT?
Yeah, sure. Sorry. So a CRDT is a conflict-free replicated data type. And the notion of a CRDT, if anyone who's familiar with Git is sort of implicitly familiar with the idea of a CRDT. A CRDT is, Git is basically a type of CRDT. The purpose of a CRDT is to be able to have multiple instances, maintaining data stores, make changes to that data, and have the data synced in a way such that all of the instances will be eventually consistent if they all, to the extent they're all communicating with each other. So like, in Git, you can make a change, sync that with master, or sync that with some server, and then other people collaborating on the code with you can sync from that server, and you will all end up in the same place if you're all like, pushing and fetching enough. And that's basically what a CRDT is. The Merkle piece is, there are different ways to do a CRDT, and OrbitDB is a CRDT that works by adding every new entry, like hashing every new entry, and linking it to the previous entry, or to the hash of the previous entry, and then making a kind of open-ended Merkle DAG, I suppose, of entries. And then, like, to kind of create the canonical state, OrbitDB will run through that DAG from the latest, like from the head, so like the latest entries first, all the way backwards to the beginning, and like turn all the different changes that have happened into some type of like unitary state. And the trick with CRDTs is that, or the catch with CRDTs is that the changes all have to be commutative. Like you can't protect against double spends with a CRDT. You can't say like, don't let someone spend money if their balance is 0, because one part of the state might not know that their balance has already become 0 because of changes in some other part of the state. However, you could make a CRDT that said, all right, everybody has money and just keep track of their balance, and it's okay if they go negative. That would work in a CRDT. So that's like an interesting difference between a CRDT and blockchains, and a limitation of CRDTs. One way to think about CRDTs is, or generally like this family of approaches is like, if you relax some of the constraints or some of the requirements that blockchains have for finality and for like for the consistency of each change against some global state, or the like permissibility of each change given some global state, then you can free yourself from a lot of the performance problems and complexities that blockchains have, and get something that's a lot faster and simpler. But you don't have that like guarantee that every state change is valid against the whole state as it exists. Instead, you get you have to have like, you get validity within like commutative changes. There's something, if you can reverse the order on things and it ends up in the same place in the end, like that's cool in a CRDT. I don't know if this is clear, but
it certainly helped me. Yeah, thanks.
Cool. So OrbitDB is a CRDT. It's a fairly established one, and one cool thing about it is that it's very closely coupled to IPFS. So it and particularly IPFS PubSub. So a lot of CRDTs are like the leading, most well-known one is AutoMerge, are sort of standalone libraries that just sort of say, okay, give us your transactions and we will merge them in a CRDT way. But they don't really say anything about how those transactions get sent between different instances or devices. You're on your own for that. Whereas OrbitDB, because it builds on IPFS PubSub, it kind of comes batteries included. where you don't just get the like logical piece of CRDT, you get the like peer-to-peer layer, or a lot of it. The actual mechanic through which, you know, my phone and my computer are going to get synced. You get that from OrbitDB right out of the box. And there's only a couple other solutions that give you that.
And
And
the dumb question I have now is, does this mean IPFS is running over Tor? The way it's set
yes.
up? Yeah.
Yeah. So IPFS is kind of neutral as to the transport you use, or it allows lots of different transports. There isn't a first class one for Tor yet. There will be someday. Or there isn't like an official one for Tor. So what we did in order to get this property of like just connecting over Tor and working with IPFS is we use the IPFS has a WebSocket transport, and Tor is optimized for, you know, web connections anyway, or the Tor, like that just works fine over Tor. So we just call it WebSocket. So WebSocket over Tor. We made our own kind of IPFS transport that
cool
is just a small riff on the WebSocket one, and it works great. And we can also do authentication. So like we use when you join a community, you're given a certificate by the community owner, like a standard X509 certificate, and you can use that to authenticate with other peers when you connect to them, to prove that you're actually supposed to be in the community. So we can also use just like web standard like client server authentication for authenticating between peers. And yeah, that's all in a family of stuff that we had to kind of figure out on our own. Let's see, I'll finish explaining how the OrbitDB piece works, and then I'll talk about the other piece that's a little bit of onboarding and how communities get like created and how peers authenticate. But
right, yeah, because we didn't see that actually happen, did we? That's a thing. That's a question mark if you don't have a server.
yeah, I should show that part. Let's see.
You could finish this, and then we
Okay.
can go figure that out. Yeah.
Okay, cool. So when you send a message, it works its way down through the React stuff, through the Socket.io connection into the backend. The backend adds your message to OrbitDB, and then OrbitDB does a few things. It hashes the message, or it adds it to its store, hashes it, links it to previously known messages. There's a notion of like a Lamport clock where your messages are all in a kind of logical order, so that you can't like, so that it does a few things, but one thing it does is it makes it so that someone will know if they missed messages from you, and anyway, then once OrbitDB has kind of added the message to its own state, it broadcasts it out on IPFS PubSub to all the peers that you're connected with in IPFS. And now another note here is that we are not using the global IPFS network, because that would create like serious performance problems because it's so big and noisy, and also would create privacy problems because you'd be broadcasting like stuff about who you wanted to connect with to this big global network. And instead we use like individual networks for each community. Right now you're only allowed to have one community in Quiet, but like eventually we'll let you have multiple communities, that way you'd have multiple Slack workspaces or Discord servers. And each one of those will be its own separate network. So like there just won't overlap at all, and each network is totally self-sufficient. And so what OrbitDB is doing is when it sends a message, it's broadcasting that message, it's broadcasting not the message, but the head of your new Merkle graph, Merkle DAG, to the network. And when other clients in the network see that message through libp2p and PubSub, they will either say, oh, I've already seen that, I don't need to fetch it, or they'll say, oh, that's new, I need to do a fetch. And then they use the IPFS mechanism for fetching data, which is called bitswap, which is something like BitTorrent. Like it's a kind of like, what blocks do you have? I have these, you have those, like let's like get each other's blocks. It uses that to fetch the data that it doesn't have. And then and that's pretty much how the message propagates through the network. And files are just like links in messages to content addresses in IPFS, so like a hash of the file, and it only exists in that IPFS network for the community itself. So it's not like broadcast on the local IPFS network. But yeah, when a file's in a message, the client just fetches the file using IPFS.
Cool. This is for something that you've just pieced together from off-the-shelf stuff. It's a really elegant and I think unique architecture.
Yeah, and I think the piece that's like the one piece that I haven't talked about yet that's necessary for making it work is like the initial onboarding. And the way we do that right now is sort of incomplete, but it works. But it's almost a placeholder for, I think, something more robust and flexible. But right now, the way it works is if I want to invite someone to a community, I share an invite code with them, which in the future will be a link, but right now it's just like a code. They copy it from wherever I sent it to them on Signal or somewhere else, and they paste it into Quiet. And that invite code is just an onion address for me, the community owner. And I, the community owner, have to be online for them to join. And they, their client connects directly to mine. And then there's like a conversation where they send me a certificate signing request with their username in it. I sign their certificate and I give them peer information to connect to other peers in the community. And then they are fully a member. I also add the owner also adds their peer information to a user, like a table in the CRDT that lists users and public keys, so that all the other peers in the network will also have their information and know that they joined and be able to connect to them in the future. And then they're joined, and then we're back in the situation where everybody's connected and can kind of happily send messages to each other. But in the future, the downside of that approach is that it's a little bit brittle because it puts a lot of pressure on just like being able to make one connection to this one user in this one moment. And Tor sometimes isn't totally reliable or can be a little slow. It would be better if we were able to connect to multiple peers in that like initial joining process. And also the requirement that the owner has to be online in order to invite people is totally not something that you'd expect if you were coming from Slack or Discord, and it's very onerous and annoying. So we're going to have to like introduce some flexibility there. And yeah, the invite will include like some set of peers, and any one of them will be sufficient to get you online. We're also thinking about like how to encourage users to add multiple devices when they first join, like, get people to connect their phone and, or if they join on their phone, get somebody to connect their laptop or a desktop computer. Just generally like the more devices, the better everything works. Phones
Just
especially are great.
To bootstrap the local network, basically, for the community.
To have like the more peers you have online, the better, because you have a lower chance of either nobody being online or the only people being online being like, for whatever reason, slow to connect.
So if you're the only person online after the whole bootstrapping process or onboarding process, can you type and people will see what you typed later?
Yes, you can send a message and people will see what you sent later. But there's some UX around that we have to resolve, and the best way to avoid it is just to have a lot of peers online.
Right. Okay. Cool.
we actually thought it would be more annoying than it ended up being. Like even before we had mobile support, it didn't annoy us that much. That this problem of like sending a message but no one's online to receive it, and they get it later, and now you have this like old new message. It's a little weird, and there's some UX innovation we need to do, but it seems solvable. But it really rarely happens, and especially once we started using Quiet on our phones, like once we had an Android release and we all are walking around with it in our pockets all day, it was just so rare that there was no one online, like, and it just kind of works. And we're a team of like 5 or 6 people using it on their devices, so it's like, a group of 5 or 6 people basically is like a totally enough to make this very, very indistinguishable from like a normal centralized service.
Very cool. So should we maybe look at what someone would want to do if they were going to try to contribute, try to build it themselves?
Yeah, sure.
I know you
So
probably don't want to go through that process, but there's a README, I know.
yeah, so let's see, github.com/tryquiet. Let's see, the main repo is quiet, so tryquiet/quiet. And there's a README. The README is a little bit user-oriented, or just gives a general overview. And let's see, there's this link, developer setup. The main instructions for getting started are in the README for the desktop package.
Okay.
Quiet.
Cool.
And
but you have it linked at the top anyway, so
that is linked to from the top now, developer setup. Yeah, and here it's make sure it's very sensitive to the version of Node you're running. So use npm, get this version of Node, npm install, npm run learn a bootstrap, and then that's in the main sort of quiet folder because you're building everything then. And then once that's done, go to quiet packages desktop and run npm run start. On M1 Macs, I'm not sure if this is still necessary, but if you're on an M1 Mac and you run into issues, you might want to try these instructions. You have to, it's a little annoying because you have to like upgrade. You have to get it to use a newer version of Level Down than is requested by OrbitDB. So because the older version didn't support M1 at all. So there's a little bit of a wrinkle there, but it might be updated. There's in the develop branch now. Oh, you should probably do this on develop rather than on master because there a bunch of changes have happened since master. Or, sorry, since we last updated master. And I think yeah, it might you might not run into problems in M1, but you might. And please reach out to me. Let's see. You could reach out to me on Twitter. I'm Holmes Worcester on Twitter, or Try Quiet on Twitter, try_quiet, or just like h@tryquiet.org.
Cool. I will find out whether you have to do the special instructions for M1 because I'm too lazy to try them. So I have the setup in progress, and I thought, yeah, I'm just going to see what happens if I don't follow them. At least I'll see the error that you got. And
I think there's a good chance you're going to be okay. If not, like in a few weeks, you won't have to go through that. There's just like there's some old dependency that doesn't know about M1s, and we have to update it.
Cool. So when you do npm run start, assuming everything worked okay from the desktop package, should actually start up this chat interface.
Yep. And then you let's see. Then to use it, you could there's another trick that's helpful. Let's see. Do we have this in here? I should post this to the desktop instructions. There's another trick where you can set an environment variable data dir before you run it. So let's see, terminal. I'll just like make this really big. This is the way I would typically run quiet. You get some more logs if you use the environment variable debug equals, and it could be star. That'll give you a lot of logs. What I end up doing is backend star or state manager quiet. But this is what I was going to mention is if you want to run multiple instances of quiet on a single machine and a single user account, you can use this environment variable data dir equals, and then just an arbitrary name that's different than the default.
So if you really want to be a member of multiple communities, you can build quiet yourself and do that.
Yeah, that's what I've been using. Like when people invite me to their communities, that's the hack I've been using. We're going to obviously make multiple communities the first class thing in quiet, but we, just haven't gotten there yet. But yeah, it's super useful for development or demos, for example, to be able to run multiple instances at the same time. You could also let's see. The app's previous name, a previous iteration was based on Zcash, so it was called Zbay. But anyway, this is where the app is in the Play Store. it's very hard to find searching. If you're searching for it, I would just search for the name of our company, which is eBay LLC. Kind of a branding issue there, but we're mostly still like dog food, using this just for dog fooding. It's not like, I guess there's a link to it on tryquiet.org as well. But anyway, you could use the mobile app as like a companion to have something to test against when you're developing locally.
Great. So is there anywhere that a developer might want to start in terms of places that you would like people to try to contribute?
Yeah, good question. So let's see. Back to, do I have another tab here? I guess I closed, no, here. So let's see, I think we have, there are some, well, I don't know. I think GitHub exposes this to others and might not. There's some place where GitHub exposes this good first issue list. But anyway, there is a label in our GitHub project, or sorry, there's a label in our GitHub issues called good first issue. We're using GitHub for all of our project management right now. So there's a ton of open issues that basically describe like all the things we have to do and all the things we've thought about. But if you use this label, you will get a list of things that are fairly light and don't interact with the backend or peer-to-peer layer that much, but are still significant. Some very small front-end things like this or this, or yeah, kind of small front-end things. And I think this would be a really helpful feature that we're going to do soon. Some of these are things where, yeah, if you're not sure how fast you'll be able to move through an issue, maybe ping me to see when we're likely to work on it. Some of these we might catch up with you on, or you might be on the critical path soon. But yeah, all of these are fairly like good issues to dip your toes in on.
I love this sort of thing as a developer because, like, if the task is read all the source code and try and figure it out, it's like kind of difficult. But if it's try and make it so you can send a multi-line message, even if I don't do it, at least like I go through a path of exploration. It's more direct. Yeah. It helps. So that's really friendly. That's a good first issue idea.
Yeah. And so, yeah, and actually, I just put this up this week because we've had a few people interested in contributing who were working on getting set up this week. And so I went through and updated this set of good first issue issues. And yeah, and then also if you want to kind of see where the main space we're working out of, that is in projects. GitHub has this new thing. Let's see, wait, hold on. Oh, I guess it's it might be at the org level. Yeah, sorry. Org level projects, and then there's a, GitHub has two categories of projects. There's projects classic. We have a classic project apparently. And this is the main project we're using for organizing things. Desktop backlog, or desktop and backend backlog, mobile backlog. Next sprint, we're doing like a more kind of hybrid sprint and Kanban where we're not doing like timed weekly sprints. We're doing like do it until it's done sprints. The sprints describe like one release cycle, not like a time period. And then we're next sprint, and this is what we're working on now, and our QA process.
Great. Well, thank you. Is there anything else that you want to point out or reference before we end this?
Yeah, I guess I would just say that, well, to build on what we were just talking about of people contributing, that like when Quiet might be a really cool project to contribute to, because I think if you set out to make if you're interested in this idea of like building apps that are very private and censorship resistant and very rooted in free software and not dependent on servers run by other people, to try to give users that experience of like apps that are fully on their side and have that like cleanness that like the 2000s era open source apps had, and apps that feel really trustworthy and really like solid. That if you're interested in building something like that, like a peer-to-peer app that people are going to use for collaboration, and you go off and just start doing it, you're going to you're going to have to kind of choose between a dilemma of sorts. You're either going to have to build like a very toy app that is never going to, or that is not really going to work on phones. It, work in a browser, but only with help from a server, probably a unturned server, like the kind you need for video calls, or you'll need to use some big global network that'll give you performance problems sometimes, or rely on like, servers provided by some big global sort of peer-to-peer network to like improve performance the way a lot of people rely on IP servers in the IPFS ecosystem. You're going to have to build something kind of toy that like makes a bunch of compromises with centralization, or you're going to have to go down this long road of slogging through figuring out how to get everything to work in a way that users expect on the devices they expect without depending on servers. And if you are interested in this and you start by contributing to Quiet, you'd be able to make progress fairly quickly on features that you can like that you can see that you can use yourself. And we've already done a lot of that slog. There's still much more slog to do, but like we already have a basis where you will be able to use your features on desktop and mobile, and use them to talk with us and hang out with other Quiet developers and other volunteers and other people who are interested in the project. Just like, maybe within a day or two of starting, maybe within hours of starting. So there's something kind of cool where you can just like jump in and work on something that's really rigorously peer-to-peer and encrypted and private, that is or that is like on that path at least, that's like ready now and works now on computers and, well, Android phones, soon iPhone. And yeah.
I will say that sounds appealing to me as a developer, and as an introvert, hanging out with other Quiet developers sounds appealing. We have one last question from the chat, which is, do you have any automation around Android app builds?
Yeah, everything's in CI. And I think there's a Docker. So if you're starting on Android, I'm not sure what the context of the question is, but if you're interested in developing and want to work on Android, reach out to me. There's a Docker image that our team's been using internally. And then yeah, you can actually, if you're interested in our CI setup, that's in GitHub Actions, and I think it's all visible.
The actions are actually specified as YAML files, I think, inside the repo. Once you
yeah. So yep. So if you look in Quiet, the Quiet repo here, then you'd be able to see what we're doing CI wise, I think. And oops.
And the context he clarified is, can you compile your dev branch into an internal release APK?
Yes. You mean if you want to sort of make your own APK yourself from the code?
I think so. Yeah. And
yes.
Further context, I believe this is the creator of the Puma browser asking this question, so he probably has questions about his own Android build, I'm guessing.
Oh.
Hi, Yuri.
Yeah. So yeah, we have you will reach out, and I'm open to show you everything we have, and we could even have a quick sometime next week we'd have a quick call with the person who did all the work on Android to kind of give you an overview of what we did and where it's at. We haven't really smoothed over like the Android side for like developer onboarding. Like we haven't tackled that yet, but we will at some point.
Cool, thanks. All right, well, this was really good. I'm inspired by like all the tech stuff. Yuri says hi quietly, by the way. uh, all the different tech layers. You know, I was already inspired by the project itself and the goals, and like totally resonate with me, obviously. But thank you so much. I hope that I will be annoying you with probably incorrect PRs or something in the future.
Every PR is a good PR from our point of view. I'm
Until the
super.
fifth one.
Well, yeah, as long as they are not malicious and very cleverly subversive.
Mhm.
Yep.
All right. Well, thank you so much.
Okay. Thank you.